Assalamualaikum warahmatullahi wabarakatuh. Uh, my name is Muhammad Faiz bin Muhammad Zaini from Group 5. Today, I would like to share to you about the system that we have created. The system we call Burgeria ordering system. Before I explain our system, let me introducing you our teams. First, my name is Muhammad Faiz bin Muhammad Zaini. Secondly, we have Muhammad Alif Fahan bin Abdullah Hatim. And lastly, we have Abdul Hakim Aiman bin Abdul Jalil. That's our team. Okay, first let me start our presentation. First, I would like to share you about the introduction about our system. The Burgeria order system is a terminal-based console application to digitalize food order management. At this modular system enable user to browse the menu automatically by its array and function. The Alright, let's go through about the problem statement. In our system, we have identified 5 problem statements. First problem, we have long waiting queue. Second, we have order incurrency. Third, we have time inefficiency. Fourth, poor data management. And lastly, we have overcrowded ordering area. So this is our problem statement in our system. Alright. So in our system, we also have the objective. So first, we have the automate the ordering process. Second, reduce human error, improve service efficiency, provide a clear menu display, support multiple item order, generate accurate bill, produce items receipt, and lastly we have increase operational efficiency. So this is our objective. Okay, next we have analysis. In our system, we have identified 4 analysis. So first, the problem statement. The replace the slow and error and manual food ordering process at the campus store with a automate console-based order system. Second, the menu and pricing fixed pricing. So we have provide a 4 fixed menu option store in the parallel array, such as chicken burger RM4.50, beef burger RM4.50, mutton burger RM7, and vegan burger at RM20. Third, input validation and control. This implement a while loop for continuous ordering, entering 0 to finish, and if statement to reject invalid menu selection or negative quantities. And lastly, the modular program design. The system has structured the program into 4 main functions. We have show menu, take order, calculate total, and show receipt. And receipt order quantities before starting a new transaction. Alright.
Imagine managing a busy burger stall where manual ordering error costs you time and money. To solve this, our group developed a digital system. Good day, our lecturer and classmate. Today, I will present the flowchart for our group project, the Burgeria ordering system. Our program used a clean modular design as shown on the screen. The system consists of the core main program and 4 individual sub-modules: show menu, take order, calculate total, and show receipt. First, the main program. The flow starts at the start terminal and enters process initialization to set up, erase, and reset all item quantities to 0. The program then enters a central loop calling our four modules sequentially: show menu, take order, calculate total, and show receipt. After that, if it asks the user, add more, if Y or yes path, the system reset the quantities and repeat the loop. If N or north path, it print a thank you message and terminate at the end terminal. Moving to our first module, show menu. When called, it print the menu header Burger Ramlah. Then it execute loop I equals 0 to menu size -1 to print each burger name and price. Once that once done, it exists using the return command. The second module is take order, which handle input. It prompt the user to input an item number into item num. If item num equals 0, it's yes, the ordering stop and it execute a return. If no, it validate the item number bound. If valid, it asks for the quantity. If the quantity is positive, the system update the quantities array and loop back to take the next order. Next is calculate total, which process pricing. The variable total is initialized to 0 using a loop from 0 to menu size -1. The system multiplies the price of each burger by its order quantity and accumulates it. When done, it sends the final sum back via return total. Our final module is show receipt. It first print the receipt header and column label. Inside the loop, we implement a nest decision structure to check if quantities more 0. If yes, it print the purchase burger name, quantities, and subtotal. If no, it branch to the left and skip the printing so unpurchased item would not appear on the invoice. When the loop status is done, it goes to the right to print the footer and the grand total price before ending at the return terminal. In conclusion, the flowchart for our Burgeria ordering system correctly uses standard programming notation: oval for terminal, parallelogram for input or output, rectangle for processes, and diamonds for decision. The structured design ensures our C++ code runs smoothly without error. That's conclude our presentation. Thank you very much.
Okay, Assalamualaikum. Today I'm going to present our coding for this project. Okay, first, to keep the code clean, modular and easy to maintain, I utilize function declaration at first, including show menu, take order, calculate total, and show receipt. Then, first, the show menu function loop through our available menu items using a fixed array size of 4. It neatly formats and displays the burger name alongside their price using set precision to ensure the currency is using ringgit Malaysia. Next is the take order function, which handles customer selecting using a while through loop. It runs continuously until the user input 0 to finish order. To ensure robust handling, I built data validation into the system. If a user input an item number outside the 1 to 4 range, they enter a negative quantity. The program catch the error and display invalid message and prompt them again without crashing. Okay, once the order is complete, calculate total. It iterates through the arrays, multiplying the item prices by the order quantity to find the final amount. Then the show receipt prints out a clean format receipt. It features a clean table layout using set W for spacing and gratefully skip any item where the quantity is 0, showing the customer exactly what they ordered and the final total. And finally, Intimate. Finally, in the main function, we initialize our menu items burger ayam, daging, kambing and rusa. Along with their respective price, their process entirely runs inside a do while loop, allowing the user to either complete a fresh order or choose add more item before checking out. That's all for me. Thank you. Right here next to mine. So if customer made a wrong input, and then it is show that is invalid, so customer need to order again. So this is our sample output, and firstly it appears our menu, which is burgers and their prices. First, customer need to order based on the number on the menu. Let's say I choose 1, and then it will ask about the quantity, and then let's say I say 2, it will loop the order, so customer can repeatedly order the burger with a different menu. Okay, let's say if customer want to end the order, it can tick 0, and then it show the receipt, and customer can add more order after the receipt pop up. So if customer say yes, I will ask again the question, so customer can order more, and then if not, the program is ended. So lastly, in conclusion, the Burgeria order system proves that a simple C++ console application can significantly improve university cafeteria efficiency by automating menu ordering. It minimizes queue time, reduce communication error, and ensure accurate billing. Through the practical application of core programming concept, like array and function, the project deliver a highly efficient, cost-efficient digital solution from the campus university. That's all for me. Thank you.